So here's example 4. Remember that the regression line must pass through the point of averages, right? That's one of the quantitative features of regression lines. And the mean of the residuals should be equal to 0, right? Approximately. One of these rules actually causes the other. So it's either that the passing through the point of averages automatically makes the mean of the residuals 0, or that the mean of the residuals being 0 causes the point of averages to be crossed through. So this problem is going to ask us basically to explore which one causes the other. So examine the mean of residuals for the regression line, which definitely passes through the point of averages. An example line that does not pass through the point of averages, right? And we should try to see, well, in that case, is the mean of residuals still 0? Or an example line that does pass through the point of averages, but has the wrong slope, right? So for any slope of a line that passes through the point of averages, but is not the regression line, right? And then finally, we want to discuss this question. Is it good enough to define the regression line as the line that makes the sum or mean of the residuals 0? Well, let's see. If you click on example 4, I've put back the pizza example that we covered at the very beginning. And here I've put in our regression line, which had $4.75 as sort of the base rate, and then 12.5-cent increase for every gram of fat, right? And I've already calculated for you the predicted cost, the residuals, and the squared residuals, because we actually already did this in the first problem. The only thing I've changed is I've also provided for you the sum of the residuals. And here we find that the sum of the residuals is 0. Now let's think about this regression line. It definitely passes through the point of averages, and the sum of residuals is 0. So this regression line definitely fits our quantitative definition for a regression line. And it has a very low squared residual, sum of squared residual. Now, given this line, let's think about a line that does not pass through the point of averages. Now, if we take our line, and we shift it just very slightly up or down in either direction, right? It won't pass through the point of averages because parallel lines never intersect, right? And so we could keep the same slope, 0.125, but we could just change our b sub 0 very, very, very slightly. We could just change that intercept very slightly. Maybe we'll move the line up just a little bit. So we'll make it 4.8, right, instead of 4.75. And here now our line is y equals 4.8 plus 0.125 times x. All right, so let's find the squared residuals and all that stuff. So the predicted cost would be b sub 0 plus b sub 1, and lock that in place, times x, right? And notice that our predicted costs are very, very close still because our line is not that far off. And let's calculate the residual. So the actual cost minus the predicted cost. And let's also calculate the squared residuals. I'm just squaring each of my residuals. And they're being added up down here. Notice that although these sum of squared errors are very close, this one is just slightly bigger than this one. So it's a slightly worse fit than this one. This one is a better fit. But let's check and see whether our residuals add up to 0. And it doesn't. It's very close to 0, but it doesn't quite add up to 0. And so these lines that don't quite pass through the point of averages are, even though they're only a little bit off, these do not add, some of the residuals do not add up to 0. Now that we have all this set up, we could actually just change this slightly. So now let's move the regression line down just a little bit. Let's just move it down slightly and make this 4.5 instead of 4.75. What if we do that? Well, again, it's not that far off. It's still pretty low sum of squared error, but the regression line is still the lowest, and the residual still doesn't add up to 0, right? So, so if it doesn't pass through the point of averages, then it's off by a little bit. The other thing we could do is we could keep the intercept the same, and instead we could change the slope by a little bit. And if we do that, then we know it doesn't pass through the point of averages. And when we do that, what we find once again is that the sum of squared residuals is more off than our regression line, and our sum of residuals still doesn't add up to 0. So although we've tried a couple of lines, if it doesn't pass through the point of averages, we see that the residual doesn't add up to 0. Now let's talk about the flip side, a line that does pass through the point of averages, but it's still not the regression line. Well, in order to find one that passes through the point of averages but has the wrong slope, it's nice to sort of figure out from our actual point a line that passes through there, but has just a different slope. So, you could pick any slope you want. So I'll pick a slope of 5. Rise 5 over 1, right? And now let's find b sub 0. We could just use that same formula we used and plug in our values for the point of averages, right? So that would be y minus x times b1, and our b1 is right next door. Right? So this is a point that definitely passes through the point of averages, but obviously has the wrong slope, right? So let's find the predicted costs. Remember, this is a line that I just totally made up. So the predicted costs might be very, very off. So predicted costs would be the intercept. I'm going to lock that in place. Plus b1 times x, and I'm going to lock b1 in place, b sub 1. All right. And so we see that the costs are fairly off, right? Negative $31. This one's pretty close, 18, but this one's pretty far off, 68.5. Now let's find the residual, the actual cost minus the predicted costs. And finally, let's find the squared residuals. Notice that the sum of squared residuals is very, very off. 4,753. That's pretty off, right? So we know that this isn't a great line. It's not a well-fitting line. These other lines actually fit better. But let's check the sum of the residuals. What does that add up to be? What do you notice? That has a sum, the residual sums, the sum of the residuals is 0, right? Just because this line passes through the point of averages, right? Because remember, in order to calculate residual, all we're using is x bar and y bar. And so it actually makes sense that as long as it passes through that point of averages, the residual is really going to be, the sum of the residuals is going to be 0. But what's cool about Excel is now that we have all of this set up with all our nice formulas, we could actually put in any slope. So let's put in negative 0.1. it'll find the b sub 1, and this line perfectly passes through the point of averages. Even though our sum of squared residuals has improved, our residuals still add up to 0, even though it's not the line of regression, right? Let's try another one, negative 0.00035. Oh. So Excel will do this just because it's too many decimal points for it to show you, but still you get the idea. And this, although it looks sort of like a crazy number, this means that you need to move the decimal point to the left 15 times, right? And so that's very, very close to 0 still, right? Let's try another one, 500, right? Once again, we see that the residual, the sum of the residuals is 0, right? So even though these are obviously not very good lines, they're not very good regression lines because the squared residuals are terribly, terribly off, the sum of the residuals is 0 as long as the line passes through the point of averages. So let's go back to example 4. Here, we've seen the mean of the residuals, or the sum of the residuals, similar idea, for the regression line. And so the mean of residuals equals 0. An example line that does not pass through the point of averages, so mean of residuals does not equal 0. And an example line that does pass through the point of averages but has like completely the wrong slope. And here we find the mean of residuals, once again, equals 0, right? So is it good enough to define the regression line as a line that makes the sum or mean of the residuals 0? No, that's not good enough, because any line that passes through the point of averages will have the sum or mean of the residuals as 0, right? So this one really causes that one, right? And so we also need to have all those other rules. For instance, the other rules being the sum of squared errors is the lowest in a regression line. That definitely has to be there. So